All right, guys, we're going to talk 7.1 and 7.2 is solving systems of equations. This is generally what we do before we do the 3 variables and the 3 equations, but I just figured this would be easiest to end with. You guys have seen the beginning stuff before. You're familiar with elimination, you're familiar with substitution. I don't care which one you do. But in a case like this, number 1, what is easier to do? To eliminate one variable or to solve for one variable and then plug it back in? Okay, any way you want to do, you guys can do this. If you want to, I'll do this 2 different ways so you guys can see. Would it be easiest to solve the first equation for x? Okay, so you could rewrite this as x. When I move 5 over, this becomes negative 5y plus 42, right? And then you would take this and plug it in where? To the second equation. So you'd have 8 times negative 5y plus 42 minus 3y equals 35. Now what? Distribute. So I have negative 40y plus, what's 42 times 8? Don't tell me big number. What's 42 times 8? 336, okay. Minus 3y equals 35. So now we combine like terms, yes? So negative 43y, and then I'm going to subtract 336 from both sides. So what's 35 minus 336? What is it? Negative 301. All right, and then we do what? So divide both sides by negative 43. So what's 301 divided by, negative 301 divided by negative 43? 7. All right, now that I found out that y equals 7, how do I figure out what x equals? Okay, plug it back in. I'm going to plug it back into the top one because that's easier. So I have x plus 5 times 7 is 35 equals 42. I subtract 35 from both sides, and I get x equals what?
7.
Positive 7. So you would write your answer as 7, 7. All right, that is not new information. You guys should have learned that in Algebra 2. Should have probably learned that in Algebra 1. Now, some of you are, I am some of these people. I don't like substitution. I can't stand it, actually. I like elimination. So if I'm going to eliminate, I'm going to do the exact same thing, guys. Solve the exact same equations, but I'm going to eliminate. I personally would eliminate the x variable rather than the y. How come? You could just multiply the top by negative 8. Just easier. So I'm going to distribute here. I have negative 8x, negative 40y, and then negative what? Negative 336. Does that look familiar, guys? Yeah. If you notice, using either method, you'll get the same thing because you're doing the exact same thing. It's just kind of a different way to get there. This cancels. I get negative 43y equals negative 301. Then I do what? Divide by negative 43, and I get y equals 7. Then what do? I plug back in. I would have gotten 7, 7. I do not care which way you guys do it. These are linear equations. How do you know they're linear? What are the x and y to what power? First. To the first, all right? We're going to do some nonlinear ones in a second, and it just means it's to the second power. If you have a question that involves fractions, many of us in here say, oh my gosh, I hate fractions. Do you have a way to work with this where it's not a fraction?
Yeah, you can multiply everything by
I could multiply this whole top equation by what number? 8. So think about this. When I do this, I have 8 divided by 2 gives me,
4.
so I have 4x. Multiply here. 8 divided by 8 gives me 1y equals multiply here. 24 over 8, which is 3. Here's my new set of equations. Anytime you have a fraction, guys, just multiply by whatever the common denominator is. Get rid of the denominator. If you have a decimal, multiply by 10 or 100 to move the decimal. It's not a big deal. You can do that as long as you do it throughout the entire equation. So now that we're here, right, you can either use elimination or substitution.
Elimination.
Elimination, okay. So what do you want to multiply?
-1.
The bottom or top? Okay, so look, I'm just going to multiply by -1. So what does it do to all the signs? It changes them all. So now when you combine, what's 4x minus 4x? 0. What's negative y and a positive y? 0 equals -3 positive 3. 0. What do you think happens, guys, when you everything cancels out? You get 0 equals 0. Infinite. All right, there is an opportunity or a possibility where everything cancels out. It's infinite many. What happens if you get an untrue math statement like 0 equals 9? No solution. See? You guys are fine. Everybody's good. We're good? Okay, now let's look at this one. This is a little bit different. Why is this one a little bit different? Because there's an x squared. Now, you can do this one of two ways, guys. I'm going to do it both ways. Is this already set up so it's easy to do substitution?
No. Yes.
The second equation says y equals. So can't I just take this and plug it in right there? Okay, so let's do that. I'm going to do it over here. So I have 2x squared plus 2x. Here's where you got to be careful. What sign is in front of that y? A minus. So I got to put this in parentheses. 2x plus 3 equals 15. All right, so guys, basic algebra. What do I do with that negative sign? Distribute it. So I have 2x squared plus 2x minus 2x minus 3 equals 15, correct? All right, what can I do?
Add the 3.
Okay, I can add 3 to both sides. Perfect. What else can I combine?
Oh, sorry. 2x.
Negative 2x and positive. This just cancels, right? So you have 2x squared equals, what's 15 plus 3? 18. How do I solve for x?
Divide by
I'm going to divide by 2. Perfect. So I get x squared equals what number? 9. When I solve this, guys, I take the square root, yes? What goes in front of my answer? Plus or minus 3. How did I already know from the beginning that I was going to get two different x values? Because it's squared. How do you figure out the y's? You have to plug in positive 3 and negative 3. You can plug it into either equation. Which one would be easier? The second one. So I'm going to plug in where x equals positive 3. I'm going to plug in where x equals negative 3. So 2 times 3 plus 3 equals, should probably write down the number I say, right? So 6 plus 3 equals, so y equals 9. Okay, so this ordered pair is 3, comma 9. Over here, when I plug in negative 3, I have 2 times negative 3 plus 3 equals y. So negative 6 plus 3 equals y. What does y equal over here? What kind of 3? Negative. So over here, my ordered pair is negative 3, comma negative 3. So how is nonlinear a little different? Whatever the highest exponent is, that's how many of those answers you're going to get. Now, some of you are like, oh, I just can't stand substitution. That's fine. You can do elimination here. How could I do elimination?
Multiply the, or actually you just switch. Multiply the bottom by negative.
Multiply the bottom by what?
By negative.
By a negative. Okay. What I am going to do first, I'm going to rewrite this as 2x. I'm going to move this over here. So minus y equals negative 3. Do you guys see why I did that? So your variables are lined up? I'm actually going to cross this out now so we don't see it. Now, you can get either x or y to cancel out, whatever you guys want to do. I just have to multiply something by negative, correct? Okay, so what's going to happen here? What do you guys want to multiply what by? Bottom by negative 1, so this becomes negative, and this becomes a positive. Everybody agree?
Yeah.
So now when we combine, guys, what is that? What happens here? I have 2x squared. What happens with positive 2x and negative 2x? They cancel. What happens with a positive y and a negative y? They cancel. What's 15 minus 3?
It's 15 plus 3.
Say it again.
It's 15 plus 3.
It should be, yes. 15 plus 3. Thank you. 18. Now what happens? We divide by 2, and x squared equals 9. So what does x equal here? Plus or minus 3. Guys, the exact same thing. There's always somebody that tells me, well, when I solve it one way using elimination, I get a different answer than substitution. That's because you did something wrong. Everything will, either method will work. You just have to keep squared stay with squareds, y stay with y, x stays with x. Either way you want to do it. Does that make sense? All right, let's look at a couple more. Yeah. Let's look at a couple more, and then I'll finish up later. All right, every one of these is a little bit different. That's why I'm doing them. And you guys are just going to see a variety. Tomorrow, probably, I'll go through some word problems, and then we'll just practice next week before the quiz. All right, let's look here. What are some thoughts?
You can move the 4x over so you can get x equals equation so that you can plug it in. Is that wrong?
No, it's not, there's a million different ways you can do this.
That's not
I would multiply the bottom by 2 and then do, like cancel out the x.
Move stuff over. Okay, you could do that.
Just have it equal to each other.
Why can you just set them equal to each other?
Oh.
Good. Now, guys, if you didn't see that right away, both what AJ said and what Tamara said would work. But if both equations are y equals, what can you do with each of them? You could just say, well, negative x squared minus 2x plus 2x equals what? 4x plus 2. Since these are both y equals, all you're doing is setting those two things equal to each other. Perfect. And now this is a quadratic, yes? Move everything to one side. I'm going to move the x squared to the right just so it's positive. So I'm going to add x squared. I'm going to add 2x, and I'm going to subtract 2. You guys with me?
It's 2x. I think you just roll x, because on the top it's 2x minus 2x plus.
This shouldn't have an x. Yeah, thank you. I just got a little excited when I was writing it. So I have a plus x squared, I have a plus 2x, and a minus 2, right? Okay, so this cancels, this cancels, this cancels. So 0 equals, I'm going to write it in standard form. So x squared, what? Plus 6x. And that cancels?
Yeah.
Now, do you guys know how to solve this?
Yeah.
Yeah. How do we solve it?
Take out an x
Take out the x, you're left with x plus 6.
and then solve for
And then solve for each. So x equals 0 and x equals
negative.
-6. So I have two answers. How did I know at the beginning I was already going to have two answers? Because it's squared. What do I do to figure out what the y is? Plug it back in. Can I plug it into the top one?
Yeah.
Yeah. Would it be easier to do the bottom one?
Yeah.
Yeah. Again, whatever you guys want to do. Plug it into both if you have extra time. I'm just going to use the bottom one. So I'm going to say, okay, here y equals 4 times 0 plus 2. And here y equals 4 times -6 plus 2. What's 4 times 0? 0. So y equals 2. So your ordered pair here is when I plug in x 0, I get out y is 2. And then over here, we have -24 plus 2. So y equals what? -22. So when I plug in -6, I get out -22. Now, excuse me. If I were to graph these two equations, this one and this one, what are these? Not parallel. What are those 2 points? If I were to graph those two equations, what are those points? Where the graphs do what? Where they intersect. If you have, anytime you have an ordered pair, if you have 1, it intersects 1 time. If you have 2, it intersects 2 times. If you get an infinite, if everything cancels out, it means it's the same line. It's on top of each other. If you get no solution, it means they're parallel. Yeah. All right, you guys are so smart.
Wait, can we do 5?
Yeah, we can do it tomorrow. But yeah, we can do it.
Is D really an algorithm?
Yeah.
At least it's
All right, let's look. Let's look. There's a couple ways you can do this. What are some things? What about this? What about if I said, okay, I'm going to write this as x squared minus 2y equals 10. And I'm going to write this one. All right, so then I have 3x minus y equals 9. All right, let me space it out a little bit better. Yeah. Yeah, I'm going to do it in a couple different ways. Let me space it out a little bit. I'm going to write x squared plus 0x, right? I can even write it. Plus net minus 2y equals 10. And then here I have 3x minus y equals 9. Can I do that?
Oh, I see it. Never mind.
Well, if I did it this way, what would I multiply the bottom one by? To get something to cancel out.
-3. Oh, 2.
What kind of 2?
Positive 2. It's already negative. Oh, it would be negative.
If I multiply this by -2, guys, what happens here? I have, what do I have?
-6x.
-6x plus 2y equals -18, right? So this is not here anymore. Now can I combine down? Yeah, this is x squared. What happens with 0 minus 6x? -6x. What happens with my y's? They cancel, and then I have equals 10 minus 18. 10 minus 18. -8. Is this a quadratic that you guys have seen 952 times in your life? This is x squared minus 6x plus 8 equals 0. So then I can factor it. Minus 4 and minus 2. So x equals 4 and x equals 2. And then what would I do to find y? Plug it back in. All right, what's another thing? All right, what'd you think?
What I did was I moved it over to the second equation, so it was y equals 3x minus 9.
Okay, so you moved the 3x over here. So you had -y equals -3x plus 9. Then you divide everything by -1, so you got y equals 3x minus 9. Is that allowed? Yeah, absolutely. So then what do I do with this?
Plug that into.
You put it right here? So then we have x squared equals 2 times 3x minus 9 plus 10. X squared equals, what's 2 times 3? 6x. What's 2 times -9? Minus 18 plus 10. X squared equals 6x what? Minus 8. Are we doing the exact same thing? Yes. X squared minus 6x plus 8 equals 0. So x minus 4, x minus 2. Yeah? What's x equal? 4. And what's x equal? 2. So let's figure out what y is. Whoa, what just happened? All right, let's figure out what y is. I'm going to plug in, I'm going to use this one. I'm going to plug in 4. So 3x minus 4 equals 9. And then 3x minus 2 equals 9. No, just, I don't, why?
You can plug them into.
I know, I don't know why I did that.
Can't you just do it with the y?
So it's 3, yes, but I'm going to go back to the original. 3x minus y equals 9, right? So 3 times 4 minus y equals 9. And 3 times 2 minus y equals 9. 12 minus y equals 9. Minus 12 minus 12. Negative y equals -3. Y equals what? 3. So this ordered pair is 4, comma 3. Over here I have 6 minus y equals 9. Minus 6 minus 6. Negative y equals 3. So y equals -3. So here I have 2, comma -3.
Yeah, it's okay that you did like
Either way.
the y equals.
That's fine. That's totally fine. There's probably 3 other ways you could have done this. You could have looked at it. It does not matter. As long as it algebraically makes sense, you guys don't mix up signs, you can do it a bunch of different ways. It's totally fine. So what we'll do is tomorrow, I'll go over 6, 7, 8, 9. And then on, I don't know, at some point on Friday or Monday, I'll go over the word problems and I'll record it. And then I'll go over it with you guys again on Tuesday.
Word what?